Hi guys, my name is Eric, and essentially my project is about building a model, training one, and actually trying to predict on whether or not a passenger is either satisfied or not satisfied with the airline service. I'm using this based on the survey data that I got from Kaggle, and then after that, I would try to conclude on the best indicators that will actually influence the classification of the models. Essentially, the whole point of this project is to apply machine learning algorithms. This is where the models will be predicting on whether or not passenger is satisfied or not, as I mentioned before. The whole point of this is to really allow airlines, especially in this time when the pandemic is really bad, where airlines are actually closing down, they are actually forced to really plan on how they would recover after this, and the models will be able to give them that opportunity to do so and justify why they will want to fund a specific part of their company. This is the project architecture. There's not much going on actually. I'm only using a Hadoop cluster because the Spark feature doesn't really have the feature to store data, and I'm only using this so that I could put my data set into it. The whole point of me using 3 data nodes is so that I could actually, for future implementations, I could actually increase the size of the data set, and hopefully that could actually increase the model's accuracy. In terms of technology, I'm using Matplot library just for a visual aid, and I will demonstrate it later on. In terms of data set, it's actually about 120,000 in rows. There are actually 24 features for each row, and each row could possibly be either an integer or string or even a null. Essentially, I'm looking at the target column that's called satisfaction, and it only has 2 values, which is why it's a binary classification. The passenger will either be satisfied or not. Essentially, the whole process of my project is really just to get a general overview of the data set, pre-processing it, essentially getting rows that has null values in them, then pipeline, which essentially just means encoding them so that I would normalize the row, and then the model would be well prepared when it's tested on. And I'll evaluate them then using confusion matrix and area under the curve. So this is just a summary of my results. So let's just start with the features. I got these features based on the heat map, which I'll demonstrate it later. The accuracy was obtained using the area under the curve. I noticed that this is actually not really the best metric to actually be used to evaluate a model's performance. There are actually many metrics out there depending on the circumstances. But in this case, it would actually give us the average amount of how the models have performed. So yeah, it's quite surprising because I thought random forest would do better than the gradient boost tree. This could actually just mean that the gradient boost tree has a better optimization in terms of the classes, and it could have been able to summarize the probabilities at the end better in comparison to the random forest. Now, for the logistic regression, it's actually a lot more lower in comparison to the gradient boost tree and the random forest. And I think this is due to the fact that the classes were slightly imbalanced, and some of the independent variables that I've inputted into the models were actually quite correlated, and that could have possibly caused the model to be quite inaccurate. Let's just show you my script. So now, so this is just a general overview of the data set. This is just better understanding of what it's all about. And as you can see here, I'm actually interested in the target column here, and you could see that I would have more satisfied passengers in comparison to the dissatisfied one. This is actually not very optimal and could cause biasness in the model. This is also my target column. This is just general means and deviations of each column. And now this is the pre-processing bit. I found that there are actually some null values. You could actually see here that in this column here, I've got a couple of null values, 393. And to be exact, I've actually chose to drop these values, which could actually potentially cause the models to not be, to actually miss some data, but yeah. And then this is just, this is an interesting visualization, to be honest. If you don't look at these two, but look at this one from onwards, these are just ratings that passengers have given for each feature. And you could see that most of the passengers have actually given a rating of 4 or a 5 out of 5 for each and every single feature. This could actually tell me that most passengers are supposed to be satisfied with the airline, yes, but that's not the case because we still have about 50,000 passengers who are not satisfied with the airline. I just wanted to see this as the age distribution for the data set. And then I've then categorized each age by the class, and I wanted to see how that looked like on a normal distributed graph observation. Then this is just the numbers for each passengers in per class. And then this is just a graph to see how that looked like when a customer is loyal or not by class. This is just business class and whatnot. And this is just the portion of customers of the data set that are actually loyal, and that could actually heavily influence whether or not that explains why a customer is satisfied or not with an airline. Yep, this is where I've gotten my heat map, and as you can see here, it's quite interesting to see how so there's a reason why so one of the features that I've chosen to be really a bad feature is the gate location. You can see here that it's very badly correlated with the target column, and that's one of the reasons. And at the same time, you can see that it's actually highly correlated to 3 other independent variables, and I don't want that because that could actually cause the model to not be accurate. And then this is just me trying to see if I could find any correlation in terms of graphical use, and you can see that these two features are actually correlated. But that makes sense because when a plane were to departure late, obviously it would arrive late as well. This is just me preparing for machine learning. The pipeline is really just to to actually encode each of the feature, and then this is the encode. This is the encode output. Then this is just a bit of a graph used for each of the coefficients for logistic regression model. This is where I produce each of the confusion matrix to really quantify how I've gotten those area under the curve accuracy values. Let's just go back. Okay. So really essentially, the pros is that it's easily replicated and improved. I could just add more data set to Hadoop, and then I could actually improve the models. Cons is that it really relies on internet, and I wanted to hypertune the models, but it really took too much of a computational time, and I decided to not go with it because it would actually take up all my credits because it took a while to really hypertune one of the gradient boost models. Thank you.